Hello, everyone, and thank you so much for joining us today. And first of all, have a very happy Diwali to everyone. So, thank you so much for joining us today on such a festive season. And today, we are going to cover this particular module in this training, that is manage source control. We are having our session multiple module that is covering multiple module for this training series. So let's start and let's begin the session for today. So before we start the session, let's quickly introduce ourselves. So we are Azure Easy, Azure Talk, group based on Telegram, and these are the few people who are working behind the scene to make these events and the group community successful. So Neeraj is the founder of Azure Talk, and he could not be able to join today, but he will be. I mean, he has been continuously supporting us to, bringing in all the new content in the community. Then we have Ram Murthy, who is based out of Bangalore and who is cloud architect. And then myself, Ashish. I am DevOps architect and Microsoft certified trainer and currently based out of Bangalore. Then we have Vipin, who is based out of Delhi, and he is a Microsoft certified trainer and freelance consultant. Then we have Rahul Mathuria, who is cloud engineer and also Microsoft certified trainer. Then we have Kritika, who is cloud engineer. And then I have our co-speaker, that is Nitanshu, who is also Microsoft certified professional and a cloud consultant and based out of Delhi. So this is our core team. And today, Ashish, that is myself, will be, first taking up the first part of session, that is managing source control and the conceptual part of it. And then I will be joined by Nitanshu, who will be taking care of demonstration and lab part, which is second part of the session. And then in the last of the session, we will be having quiz. We had a quiz in the previous session as well. So we will be having a quiz in this session as well. And we will be announcing the winner of the previous session. And also whosoever will be taking part of session today will be eligible for getting another set of 6 Azure vouchers, that will be announced in the next session. So the basic eligibility criteria is you have to participate in the quiz that will be happening in the end of the session. And the second thing is you must be a registered user on Eventbrite, so that we will be matching those users who will be filling up the quiz as well as those who are part of the Eventbrite registration. And then we will be selecting random 6 people, and we will be giving away 6 free exam vouchers to those people who can take any exam from Microsoft, and they can appear for it without having any cost. So this is for today's session. We will be announcing the winner, and for the quiz that we'll be hosting today, the winner will be announced in the next session. So let's go ahead and discuss about the certificate certificate that we are talking about. So let's quickly cover up the certification path. If you are just joining this session for the very first time, so let's quickly go ahead and see what exactly the prerequisite or the learning path for the training that we are going through. So we are actually conducting the training for AZ-400, implementing DevOps solutions. For that, you have to have either one of these certificate, either Microsoft Azure Administrator, which is AZ-104, or Microsoft Certified Developer, which is AZ-204. Once you have one of these, you can appear for the exam for which we are currently having the training on various modules. So this is AZ-400. So once you have AZ-104 or 204, you can go for AZ-400, which is the DevOps certification. Once you clear one of the prerequisite and the AZ-400 exam, then you can get a Microsoft certified DevOps badge. So this is the entire learning path or certification path for this training. So possibly we are covering all the topics that is part of this designing and implementing Microsoft DevOps solution, which is AZ-400. And once you will complete the entire training, you should be able to appear for this exam. So let's go ahead and let's discuss about the skills that are important for this exam. So you first have to go through the facilitate communication and collaboration, which contains 10 to 15% of the exam questions weightage from the weightage point of view. Then we have to go through the managed source control, which is today's topic. So we have already done the facilitate communication and collaboration module, where as part of the previous session. If you could not attend the previous session, we will definitely recommend you to go through our YouTube channel that we have posted in the chat, Q&A chat. So you can go there in our YouTube channel and you can definitely watch the previous session that contains or that includes all the important topic which is part of facilitate communication and collaboration module. Then today we are going to talk about managed source control, which is 10 to 15% of the exam from the questions weightage point of view. Then in upcoming sessions, we will be covering all these remaining modules in individual sessions. Define and implement continuous integration, define and implement continuous delivery and release management. Similarly, we will also discuss separately in one of the session about developing an instrumentation strategy, which is 5 to 10% of the exam weightage. And then we will be talking about develop a site reliability engineering strategy, which is 5 to 10% in a upcoming session. And the last session we will be having will discuss about security and compliance, which is again 10 to 15%. So today we will be discussing this managed source control, which contains 10 to 15% of the exam weightage point of view. And also this is a very important and one of the most important topic when you talk about DevOps. So it starts with kind of having a version control system in your application lifecycle. Then only you can think about further things like continuous integration and continuous delivery and other most popular practices that we have discussed in our previous session, facilitate communication and collaboration. So let's go ahead and discuss about the agenda of today that will be having the manage source control. The first thing we will be talking about is develop a modern source control strategy. So how do you work on your source control strategy? What are the various points you should think about? What exactly a source control is? How do you work on it? And what are the various options you have in market that you can possibly opt from? That is the first thing that we will be talking about. The next thing we will be talking about, how do you define your workflow and how do you define your branching strategy for source code? So once you have your source control strategy, that which tool set you are going to use, how you are going to use all those things, then we will be talking about what exactly the flow of your source code from your developer to the another developer or to the another system. How do you plan all these things and what are the various options you have? What are the various tools and features that you have that can help you in implementing this particular feature or this particular practice? And then the third thing that we will be talking about, once you have your repository, once you have your version control, we'll be talking about what exactly we mean by repository. Once you have your repository, what are the various things, most important things that you need to configure? What are the various features of a repository that needs to be configured from the enterprise point of view, as well as from the best practices of DevOps point of view. So we will be talking about configuration of repository, and then the last thing that we will be talking about is integrate your source control with other tools. So how do you integrate your source control system to other tools so that you can get a better collaboration among tools as well as people. So we will be talking about what are the few of the most common tool sets or most common patterns that exist in the ecosystem that can help you to set up these source control system with those tools, and what are the benefits that you can get, or what are the value proposition that can bring into the application development lifecycle of your product. So let's start the first chapter, that is develop a modern source control strategy. The first part of this particular module, that is develop a modern source control strategy. When we talk about version control, or when we talk about any source control system, one of the most popular source control system that we are right now is in the industry is Git. So Git is a version control system which is a distributed version control system. So what do we mean by version control system which is distributed? So there are, in nutshell, there are two types of version control system. When you say you need to manage your version control on a server or something, so what you do is you have your source code, all right? So you have your source code, fine. Then you distribute this source code from one user. All right, so you have one user, you have another user, and maybe you have one system as well where this needs to be maintained or managed or what. So let's make this thing this way. So you have a system, all right, and you have one user who is working on it, all right, and then you have another user or developer who is working on it. So possibly you want a version control system which can centrally keep things there. So when you keep code over there, simply there, then this user can also connect to it, and this user can also connect to it, and they can work on their system, and they can anytime push their changes there. And this is the, any version control system, this is the way it works. Now Git is a distributed version control system. What do you mean by that? What we mean by that is that this kind of setup, client server kind of setup can be done in two ways. One way is that, let me clear this out again. So one way is that you have a server where you need to manage your code. Fine, this is your server where you manage your code. This can be any version control system, including Git. Now you have your user. Whenever he wants to have a check on this, he want to update any code, he has to connect to this system. He has, then only he will be able to do any changes over there. So whenever he want to make changes, he is always online and connected. All right, this is one way of doing things. And then there is one other way where a developer will be able to bring those code on his laptop. All right, and then the user can work on this laptop, make changes, and as soon as he can be online, he can push those changes to the server. So it is not always necessary to be connected. So he can be offline, all right, or disconnected. So what do you mean by that is, suppose this developer want to do some changes, he does not have to have a network connection with the server. He can first take a network connection with the server, fetch all the code over his laptop. Now he has a local copy of his computer, local copy of the code over here, and then he can continue working on it. As and when he can afford to have a network connection, he can have the network connection and then push back these changes. So this is what we call you know distributed version control system, because the code is distributed between server and the client. And then similarly there can be another user who can be working on another computer, all right, and he can also take a offline code over here, a code on his a local repository that we call on his local system, and then he can keep on working on it, all right, whatever the changes he is doing doing on the local system, as and when he has some bandwidth where he can get the connection with the server, he can get the connection and push back those changes. So here the user in in the the servers or central, this is called central version control system, their user has to be online and connected. In the distributed version control such as Git, it is not needed. Now we are not covering the central version control system, CVS, all right, as part of this particular course. This is not part of your curriculum, official curriculum as well, so we are not exploring this particular option. But just to be to be having a knowledge there, there is one version control from Microsoft that is called Team Foundation version control. Okay, you can go ahead and explore this thing. This is a type of a version control which is central version control system. Now the distributed version control system, that's what we are talking about, that is Git. Now let's clear this out and let's go to the next point. Now, Git supports branching. We will be coming across what do you mean by branch, and how do you create a branch in upcoming slides. But what do we mean by branching over here is that suppose you have a repository. So let's go ahead and you have a repository over here where you maintain your code. All right. Now this is your repository. Fine. This is your repository on the server. Definitely you can have a copy of the same repository on your laptop as well, which is called local repository. All right. And this is your server repository or remote repository, we call it. And a developer need not to be connected to the remote all the time. Once he has the copy of the remote on the local, he can keep on working over here, and the moment he has the updated code and he has the network connection, he can push back those changes. Then it will be available on the remote repository, and then other people can see those changes. So that's how it works. Now when we say support branching, what do you mean by that is that when you create a branch, all right, once you have a Git version control, all right, and when you create a branch, there is a way to create a branch, we will see that during the demonstration. Then what happens, the same code, all right, the same code will have a working copy. All right, it is not a copy to say, it is a pointer to that copy. So you have a isolated space. All right, how it works is that suppose, so you have a code, all right, you have a code, you create a branch. How do you create a branch? We will talk about it. You create a branch, then what you get is you get a copy of the same structure, same file system, same folder. All right, this is not a copy of the file on the disk, but it is a isolated space for you, and which points to a different location. It's kind of a pointer reference system. So that way it saves storage on the disk. It just creates a space, isolated virtual kind of space for you, and you have a branch. We normally call it feature branch. So suppose this is a feature one branch. All right. Now this kind of branching system is supported by Grid. No, in many, this is one of the very nice feature of Git, where if at all you want to make some changes, you can create a branch and then you can start working on it. And then these changes, what you're doing, these are very much specific to you. The moment you want to, you do not want to you want these changes, you can delete this branch. The code which was original code will not be impacted. If at all you want to merge or send these changes to the main branch, we call it main branch or master branch. We will see that when you send these changes to the main branch, then these changes what you have done will be merged into it. How do you merge it? We will soon see that in slides as well as in the action. But as soon as you do the changes, it is you who can decide whether you make those changes to be available to the main branch, to the main code or not. If you want to get rid of these changes, you think these changes are not no more valid, you can always go ahead and delete this branch, and then main branch is still where it was. And that way it's kind of increase the collaboration in, impacts your collaboration a lot. Now let's go to the next plant, which is code history and collaboration. Again, just like when you are talking about version control system, definitely it is one of the very very important point of any version control system, which retains code history and collaboration. So you will be, as we have just seen that, if you have a branch, you will be able to collaborate properly. Similarly, whenever a developer is creating a branch, right? So whenever a developer is creating a branch, all right, making some changes, then making those changes available and then merging those changes, all these things are historical events. So all these things are retained, okay, retained the history, and then anyone can go any point of time and can revert back those changes if at all needed, or can review what happened when and all those kind of things. So this is the way git version control helps you in maintaining the code history, as well as kind of enhance the level of collaboration you can have with other developers or other teams, because you have a very very high level of historical events data. You can retain them, you can restore them, or you can go ahead and review those changes. Similarly, when we talk about code when we talk about code history and collaboration, at the same time in git there is something called a code review process. We will be talking about how the code review process happens when we will be talking in detail. But we will be but git actually gives you the options which can help you to do the code review process more efficiently. So it is more automated. How do they do it? We will be talking about it in a slide where we will be talking in detail in one of the feature, that is pull request. So there we will see that what are the various options you have in git or in some of the toolings which are based on git, and how do you make use of it in your team or in your application development lifecycle. So this is one of the thing that is there, which helps you to implement a better code review process within a team. Whenever someone is making some changes into one branch, whether they should be able to merge back into the other branch or not, how do they merge, what are the automated validation you can have, what are the other manual validation you can have with some people, some responsible people like team lead managers or something like that. So those high level or those narrow level of approaches which can help you to better manage the code health, all those things are possible when you are using git as a version control system. Having said that, when we are talking about git, there are other version control system, but git is one of the most popular among the others. And the second thing is that it is one of the tool that should be, I mean, that is part of this course curriculum. So we are talking about it. Now let's go ahead and talk about GitHub. You must have heard about GitHub. It is a very popular tool among developers community, as well as nowadays, as and when people are talking about infrastructure as code, configuration as code, and all those things where you supposed to manage your code, manage your infrastructure as a code as well. Then this GitHub is becoming a very popular place for managing your any type of code or any type of source code that you have, whether it is infrastructure code or whether it is application code. And actually Microsoft use GitHub a lot. And if Microsoft has actually acquired this particular company. So now Microsoft is more using this tool quite extensively to manage all kinds of code, including their documentation. So whenever you hit some documentation bug, they might be redirecting you to GitHub to raise a issue so that they can correct it. So that kind of GitHub has that kind of adoption in the industry. So let's talk about what exactly a GitHub is. What do we mean by GitHub? When we say Git, and it includes Git, so how does it relate with Git that we just talked about in the previous slide? Now GitHub is a software as a service platform which is using Git. So what do we mean by that is that actually when you talk about Git, all right, so when you talk about Git is a open source software which anyone can buy, or I mean anyone can download and install on his computer. So what GitHub has done is he has taken this, I mean they have taken this particular Git system which is open source, freely available to anyone. You can take it. They have taken it, they have customized it, all right, not the Git itself, but they have using this, they have built up a platform which is a software as a service platform, and they are giving you as a service. So what do you mean by that is that if at all you want to use Git as a version control system, you don't really have to set up your own infrastructure to to have a highly available Git version control for controlling or for hosting your application source code. GitHub is one of the tool which is very popular in giving you a space which can help you to do the version control system without to worry about any cost. If at all you need a highly available system, if at all you want a system where security are in place, it is highly available, it is built upon a very scalable infrastructure. So those things GitHub has done for you. They have done some customizations as well. So that is how GitHub and Git are related to each other. Now when you talk about customization by Git, customization by GitHub of the Git to make it possible, to make it more user friendly, they came up with a kind of a flow where you can work with that particular flow, so that uses of Git does not include or involve so much complexity for you. So that is how GitHub helping you to adopt Git in a better way, in a easy way. So that is how GitHub is there. And the nice thing about GitHub is it is a free software. For a limited free edition is available for you, and if you are an open source contributor, and if you are building a software or a code which is open source, it is completely free for you. It is almost completely free for you. If at all you need a private version of it, where or you are not a open source, you are not you do not need it for open source software management, but actually you have an enterprise requirement, some legacy, some code is there for which you cannot go for open source way, then they have some pricing, calculation in place. You can go there and check out what are the which particular edition makes sense to you. But in and all, if you just want to start it, you start understanding and start learning, it is a free thing for you. And what it makes, why it makes sense to you, because it is a free, first thing. Second thing is, using it is a very simple thing to to explore. They have made it very simple. They have a software, GitHub desktop, which can be installed on the laptop and can make your Git interaction quite easy. Before that, it was a lot of command line tool and all those things. When we are talking about command line tool, so this is what it is. It helps you to interact with Git using web interface. It also has support for command line tools, but also supports many of the popular IDE. IDE means integrated development environment. Integrated development environment such as Visual Studio, Visual Studio Code, Eclipse, all those popular integrated development environment does have inbuilt support for GitHub. They can integrate with GitHub. You can make, while you are making those changes into your development environment or in your tooling, at the same time you can interact with Git to publish your updated changes, to create branches, to create a pull request, and all those kind of things are possible. Certain features are limited to certain tooling. That kind of differentiation will be there, but most of the popular tools supports all major functionality that GitHub supports in their tooling system itself. You don't really have to go here and there. If at all you want to use Git with one of your tool that you have, suppose Visual Studio, Visual Studio Code, or other integrated development environment. So that's how GitHub comes into picture as a software software as a service for Git needs. When we say this GitHub, there is one more solution from Microsoft again, which is part of Azure DevOps services. We call it Azure Repos. Now Azure Repos is also one of the tool which helps you as a software as a service for Git solution. So you can use Azure Repos to for creating Git repositories for you. So you can use that particular tool as well, and it is again free to use with a limited with some limits on there. In case of Azure Repos, it's not limited. You can use it for private repositories, you can use it for public repositories. They do not have any limitation in that term, but Azure DevOps in whole has some limitations for free uses, or for for enterprise uses. So those are the things you may have to consider. But from the Git point of view, you can use Azure Repos, which is part of the Azure DevOps services, which is again giving you an option for having a Git version control. When you use Azure Repos, this particular tool we just talked about, this team foundation version control. So when you are working with Azure Repos, they also gives you another version control, which is team foundation version control, which is a central. We just talked about central and distributed version control system. Central version control system. Okay, so this one is different in implementation, different in technology from Git. So you pick one of them normally, or in recent industry trends, Git is one of the de facto tooling for any kind of version control system. But having said that, you have some requirement where you may need team foundation version control system. All right, now you can also just like GitHub, you can use website, web interface, command line, or other integrated development environment like Visual Studio Code, Visual Studio, or any other integrated development environment. Most of the popular development environment or code editor tools do have integration with Azure Repos as well. You can connect with the Azure Repos Git repository. You can do whatever the operations you may want to do. You want to make those changes available on the central server, you can make those things. All those things are possible when you are using Azure Repos or GitHub. So the choice is yours based on your industry, your organization need, based on your pricing pricing need, based on all other factors. It is up to you which one system you want to go for. Both of these systems, as far as Git is concerned, they are similar in working or functionality. Once you are familiar with GitHub, it is very easy to work with Azure Repos, or vice versa. So once you are familiar with Azure Repos, it is as simple as that working with GitHub as well. There are certain changes in terms of features, there are certain changes in terms of interface that's there, but those are not fundamental changes. They can be, you can definitely make the transition to the other tool in a very shorter period of time. When we work with any one of these software, either Azure Repos or GitHub, to use Git as a version control system in our organization, the first thing you might have to do is either cloning or forking. So what do we mean by cloning or forking? So whenever you go to any Git server, either in the within on-prem. So if you have a Git server, previously it was Visual Studio Team Server. Now it is called Azure DevOps Server. So normally people will have this Azure DevOps Server. All right. Or you can have, GitHub Enterprise. Okay, as GitHub Enterprise, or you can have any other Git, a normal Git as well. All right. So anyone, if you have any system in place, you will be getting two options. Either you can get a option for clone. It can be Azure DevOps Service as well, just to make sure. Azure DevOps Online, you call it online or service. All right. Or you can have GitHub as well, normal GitHub. All right. If you go any one of the interface, you get two options. Either you get a clone or you get an option for fork. So what do you mean by these two options? So let's clear this out and let's understand what do you mean by clone and what do you mean by fork. So clone means copy on the local machine. So whenever you have a you have a server, all right, you have a server, you have suppose you have Git, all right, and you want to make it available on your laptop, you do the clone process. So there is a way to do the cloning. We will talk about it. How do you clone the server repository on your local computer? That's that is one thing. And then there is another thing that we call is fork. So what do fork does is fork copy the repository into your GitHub account. So when you do a GitHub, all right, so suppose, let me clear this. So when you create a GitHub account, all right, let me go back, go to this particular thing. So when you create a GitHub account, normally you get a, you get an account like this, GitHub, or you may have Ashish, Raj, or something like that. So normally what you have is you have this kind of account there. Suppose GitHub has created a repository like GitHub/example. Let's clean this. So suppose GitHub has created a GitHub/example. When you fork this particular thing into your account, all right, then what it does is, suppose this is my account. So what it does is it creates the same repository under my account. So it creates a copy, but not on my laptop, not on my computer, but on the GitHub system itself. In the GitHub system itself, what it does is it takes out this particular thing from this account. All right, it will still be there, but it will just take a copy from it, and then it will it will create a this copy under my name, so that whenever I am making changes to this particular thing, all right, it will be available in my account and I am not interfering with the original content creator or original repository owner. That is the reason they have created this particular fork thing. So once you have this thing, all right, what you do is, once you have this thing in your name, all you do is you clone this particular thing on your local computer, just like you do a normal clone process. So if you go to the clone process, this is what you do. So you have a a github.com/my name slash a repository. So I have created a repository like this. I will do a git clone. I will run a git clone, and then this URL over here, this URL, I will get a URL from the interface itself. I'll put this URL over here on my computer, on my command line terminal. Then what will happen on the local computer? It will create a folder, all right, and that will be exact replica of this server. So that is how we just talked about the distributed version control system. And this is what happens when you do the cloning process. When you do the fork process, it will be little bit of one more step ahead there. Let me clean this. So when you do the fork process, what you do is you don't do the you first create a copy of the of one of the repository that you have not created. Someone else has created, Microsoft or any other company, and you think that you might want to change that particular code just to make sure it is working for you. You might want to customize it, or you might want to contribute to it. So what do? You do is you first do the fork process. All right, you do the fork, and then what you do is you create a copy of it into your account. And what does this 37 number means is that these are the number of fork that has been created on this particular repository. So like you, there are 37 other people who have created a copy of this repository into their account. This is what this this particular number means. So when you go to a GitHub account, just go there and you will be able to see some number over there in the fork. And if you click on this particular thing, what will happen? It will take some time, create a copy, and it will give you something like this: your username slash the original repository name. And this is what happened. Once you have this thing in your in your name, then you can do the clone. All right, you can do the clone with a similar way: git clone and then the url with this. All right, here you will get some url like, github.com slash your username slash the repository name, something like this. You will get it. You put this url over here, and then what will happen? The moment you run this command on your laptop or on your computer, it will create a folder in your laptop wherever you're running it, C drive, D drive, wherever you are running it. You will get a folder like this, and then you can start working on this folder. You can create files, you can change files, you can modify files. And then what happens once you do those changes? All right, you create a pull request. We will be talking in detail what exactly pull request is and how it helps, but let's see how the changes travels from your laptop. All right, so suppose you have some you have this example folder on your computer after cloning or forking. All right, once you have this example folder, you have done some changes, ABC, whatever changes you have done, you go ahead and oops, this one, you go ahead and create a git push. There is a way to do the git push. All it does is it whatever the changes you have done, it will push it where? To your, to your folder. So this is your folder, you are the owner, you can make changes. Even though this example was taken, was taken from some GitHub account, but now since you have forked it, you are the owner for this particular repository, so you can do the git push. Fine. Once you have pushed these changes here, all right, and if at all you think that these changes supposed to be done with the original author, you just want to you just want to notify that author that, okay boss, your example repository had these changes applicable that I did, and then it is working for me, and I want to share with you so that you can do those changes into your original repository so that other people will not face such issues. And this is what we call GitHub contributor. This is how the GitHub contributor works uh, in nutshell. This is how, when people say that I am a GitHub contributor, this is what they do. They take out some repository, they analyze it, they use it, and in this process they might come across certain issues, certain problems, certain modification or certain improvements that may make that particular original code better, and they do those changes and create a pull request. We will see that how do you create a pull request in the interface. They create a pull request with the original content owner, that boss, whatever the changes are there in Ashish or Sivastava example, can you please have a look there, and if you are okay with it, can you please merge it here, can you please put it over there? And that way you become a contributor for this repository, and they might mention your name. They might, you might be able to show that, okay, you have done some changes into the Kubernetes source file. You might have done some changes into the Docker file. You might have done some changes into the Microsoft document, or and so on and so forth. So this is how the Git ecosystem works from the contributor point of view as well as from the Git point of view. Now let's clear this particular thing. And okay, so let's go to the next part, which is Git LFS. Now, Git LFS, large file system, is one of the system. Normally, what happens? One of the limitation of Git is, which we have not listed over here, is that. Okay, let's go to this. So since this is your repository, all right, and this is your server, all right. Now this is your server, all right, and this is your repository. Now whenever you make some changes, all right, so suppose when the server had A and B. Now what you did is A and B was already there, fine, you did some C there, so you added C. So what happens? Git, you know just sends this C there. Okay, A and B is already there. So it is not like, it will be cumulative. It will be including A plus B plus C, and then it will be sending again the duplicate content which is already there. It will just append those changes in terms of line numbers or in terms of, files as well. Now this kind of working system where you just track the changes is good for smaller, repository. So suppose this repository is like some MB, like, 200 MB, all right, and 200 MB itself is a very large repository. But if at all this repository is supposed to have a very huge size, all right, this is like some GB kind of stuff that we are talking about, or this repository does have some binary content. Okay, so Git is very bad. Okay, Git is bad with binary content actually by default. Okay, so binary content means that if you have a .exe file that you want to track on Git repository, you have some JPEG file, okay, some movie file or something like that. These are all categorized as binary content, right? The source code is not readable and or very difficult to read. Those kind of binary content is very difficult to be tracked in Git system, and that's when the problems start happening. And that's where they have a customized solution which we call as Git LFS. Git LFS is helps you, they call it large, okay, large file system. They call it, this is what the acronym is. Okay, now Git large file system is a kind of additional extension you can think of, or additional plugin, or a extra installation that needs to be done on your computer that will help you to manage or to overcome those default the what I would say limitations that Git has. Git has limitation with large files. So large files, this particular guy, this LFS will help you to overcome this particular problem on a very large extent. Then you have this binary content that is also, binary content like, binary source code like, .exe, all right, image, movie files, or any other kind of content that you want to manage with Git. Usually you will always manage code only, which is human readable code, C#, Java, all those kind of things. But it might happens that your requirement is that where you might have to manage large files or binary content. That's where you need to explore Git LFS, which can be installed on your computer and that can be configured on your computer, which can help you to do the large file system tracking, or large file system based repository tracking on Git itself. Now this has a, a client that needs to be installed. So, it is not a default option in Git. You have to install some client there. GitHub has a support for it. So GitHub has a desktop application. Okay, if you go ahead there and search GitHub desktop, you get a exe or installation file for your, operating system version. You go ahead and install that thing. That what will give, what it will give you is a client version of GitHub, which can help you to configure your repository, configure your GitHub repository, and that particular thing supports LFS configuration. So LFS is a kind of a custom work that you need to do. It is not part of default installation of Git. Once you have done it, and once you know your requirement and you need a, a kind of a large file system tracking for your version control system, you can go ahead for this option, and this option can help you to configure your version control system for tracking the large file system, large files in your repository. Now when we talk about, let me clear this thing. All right, so when we talk about Git LFS, what it works is that you have a copy. All right, when you put the code, in Git, and if it is configured with LFS, all right, if it is configured with LFS, then what it does is it, it does two, it maintains connectivity with two things. One is this LFS location where it will manage the large files, such as binary files, and then it will have the connectivity with the actual Git where it will track the pointers for these files. So you have your working copy. It will be the actual file will be maintained on a LFS cache, which is a storage location, but repo will only point to the the most updated content. So in a way it is a pointer. All right, so that way you are able to overcome that file system limitation for your git repository system. This is how this git LFS works. Now let me clear this. And this is what you need if at all you have a kind of a requirement where are you want to manage your file system for where you have large files like binary files, image files, and all those things. uh, Next thing is git submodule, which is also one of the very important thing in case of git. So what git submodule is that normally you have a git repository, right? So suppose you have your git repository here. Oops, let me. So you have a git repository here. All right, and then you are managing this git repository. Now you have another git repository. Fine, you have another code over here. Suppose you have module A or module suppose this is master module. Suppose this is master application. This is A module and this is B module. Now each one of them are managed on different git repository. All right, now suppose this master uses both A and B. All right, so this master module does have code that is coming from A, and this master module does have code that is coming from B. So in this kind of scenario, this sub modules helps you. How does it help? Let's go ahead and see that. Let's clear this. Okay, so this helps you. So what happens normally, you have a project repository. All right, this is your master repository, what we talked about right now. Now this master repository can have a repository dependency on another repository, which is sub module. So you can create, so suppose this is A, so you can create a sub module. There is a command for it. You can create a sub module and you can refer a remote repository A as a submodule. That way what will happen, whenever there is a code update over here, the same code update will travel over here. You don't have to manually manage the code over here. Normally what will happen, if at all you are not making use of this kind of solution, then what will happen, whenever you have if at all you have a project A, right? Normally what will happen, let's clear this. If at all this submodule is not there, so what will happen, whenever you have some code over here, you need to move it here, in some folder or something, and then here also in some folder or something, and you never know if at all this particular code, suppose this B, is managed by some third party system, third party company or some vendor or something. Now how they will notify you that there is some code update and that needs to be go there? This is very difficult to manage those changes. What are those changes are happening? What changes supposed to be pull in? Should I go ahead and pull in those changes or not? Those things will be difficult to manage if at all this kind of scenario is there and you want to manage that particular thing. In that case, git sub module comes to you for saving your copy paste kind of material. It helps you collaborate better with either internal different teams who are managing different source code within organization, or it can be third party organizations or people who are outside organizations. And in open source world, this really makes sense, right? So in open source world, this is an individual entity, this is an individual entity. They can go ahead and update code at any time, and they might not notify you that okay, there is a new code available, so please go ahead and replace your existing code that you're using in your master application. So but if at all you're using submodule, there are ways to sync up your submodules automatically or manually, and that way, and also you will be able to see the history and all those kind of things that you get with git, that what are the things are coming, whether we want that or not, whether we should go for and restore back to the previous state and all. This is the kind of a thing that you get with git as a git submodule feature. With this we have kind of covered the basic functionality or the basic feature of git submodule, I mean git in whole. So you have this, if you talk about uh, git, what do you mean by this is that you have a version control system that is centrally available. one can pick it from there. All right, he can, developer can work on it. Okay, make changes, make those changes available online. Then the other developer can work on it, and then he can also make those changes as is when he wants to. There is no need to kind of be connected. If at all there is no connection, no issues. Once you have taken those codes on your laptop, no need to be connected with the central server. The moment this, the developer wants to share his code, the moment the developer is okay with sharing this code, he will go ahead and, request, or he will merge the changes with the remote branch or the remote server. And that is the way Git works, and that is why we call it distributed version control system. And that is how it works. And there are few basic things that you need to understand. That one of the basic things that we just discussed is your branching model. You need to, branches are there which can be configured. We will be discussing about how do you configure, what are the basic things that you can follow to configure your branches. What are the branching policy that you can use? How do you configure your pull request system? How do you, make use of all these types of features in your Git repository system to make it a better way to collaborate with the developers, or with other people in organization, or with the third party tools as well. So in the later session we will be discussing about that option, that particular aspect as well. So let's go ahead with the other, with the next chapter, which is plan and implement branching strategy for source code. Now, once you have configured, once you have once you have decided that Git is the branch, Git is the version control system that you are going to have, then this is the, this is the step which first thing that you need to discuss, that is branching strategy. Now, what do you mean by branching strategy is that, let's go ahead. Yeah. So what do you mean by branching strategy is that you need to use a feature branch whenever you want to make any changes. Now, what do you mean by that is, let me just, okay. So what do you mean by feature branch is that you have a version control. All right. So suppose this is your version control, fine. You have taken this thing on your local computer. This is the developer you have, all right. He has taken the version control on his. Now he has the ability, and if it is configured in that way, then he can make those changes over here. Okay, he can make changes, he can pull back changes, and then he can directly push these changes to the repository. Normally, every repository, whenever you create a repository, it will have a branch that we call as master branch. Okay, this is also called as main branch. No, this is possible that if you're starting with your journey, then it is possible that you might be, making changes on the master branch itself, and it is okay to do this in a individual, in an individual scenario where you are the only one who is working on it. But in case you are working with teams, then you should not do this. You should not, directly do changes on the master branch itself. Instead, what you should do is you should first, you should, once you have a repository like this, all right, and once you take this repository on your system, the first thing you need to do is you take a copy of it and you call it a branch A or whatever. Normally we call it feature branch, feature one. Feature branch means that, whatever the changes you want to, you want to apply for your implementation, you name that, feature here, like login branch. Suppose you want to make changes for implementing login in your application, you will name that branch as login branch. You cannot have spaces in between. Underscore or dash is fine. So this is the way you should do. We will see that this particular thing in action in detail, but you should definitely use a feature branch. Once you have a feature branch, you should always create a pull request to, merge changes. So suppose you have your, you have your Git, all right, and you taken out over, you have your local computer, fine, and you made sure that you created a branch. Okay, you created a branch, you are working in this particular branch. Now once you are working with this branch and then you want to make these changes into available into master branch, suppose this is master and you've taken this branch as your feature, we'll see that in action as well, feature one. And when you want to make these changes available to the master again, this is the, there you should have something called pull request. And how do you implement it, we will see that. But you should definitely have a pull request. What do you mean by that is, whenever someone is making some changes and he want to merge back those changes into the main branch, he should go through a pull request option. Once he create a pull request, what happens, someone who has the authority will be able to see what changes you have done, whether these changes are supposed to go into the master or not. This is the way, this pull request methodology works. We will see this in anim, on the slide as well, in the next slide. Let me clear this out. So you always have a feature branch, you make changes in a separate place. Once your changes are done, you have done your changes, you merge those changes into the main branch using pull request. Now once you have, once you have this kind of scenario, then you should make sure that, suppose you have this particular thing, okay, and you have a master branch, suppose this is the master branch, and you have another branch which is called a feature one branch. Okay, feature one. Now suppose feature one is done, and this will always come from here only, you take things from here and then you feature one is implemented, things are working. Now you should, plan to move it into master as soon as possible. So whether it take a, a request approval process or what, but your changes should not be, living in isolation. If they are done, if they are implemented properly, if all the testing is done, if everything is completed, then your isolated changes should not exist in isolation. One isolation is, the purpose of having this feature branch is just to make sure that whenever you are making those changes, if at all those changes are not going as expected, then you have the ability to keep these isolated place. But as soon as your changes are as expected, your testing is done, your dev testing is done, you are able to confirm that, okay, whatever the things that the developer has supposed to do, you should, plan your merge, so that your master is up to date with the new feature that developer has worked on. And that is what this third, this third point is talking about. You should always maintain your branches up to date. Now all this process, all this thing goes through a particular flow which git, calls it git flow. What do you mean by git flow is that you have a git repository. All right, normally you always have a kind of a master. All right, maybe a release version, a release branch with the release version, and a develop. These are called main branches. All right, normally this is main branch, this is main branch. All right, release branch is main branch or not, that is up to you whether you want to keep it or not. What do you mean by main branch is that master will always have a certain level of code which is up to date. Develop will always have a certain level of code which is up to date. Develop is something which is always having the up to date code which is under development. Master is always have the up to date code which is in the production. And then you can have a further kind of a, uh, further categorization of branches as well. But main branch is something which is already released, which is in production, so this is up to date. And develop is main branch in terms of whatever is under development, it is up to date. What has been committed, developer has done the testing, he as per his feedback things are okay, then it has to be there in the develop. At least if it is not released yet, if it is also released, then it should be in the release version as well as into the master branch. This is what we call it, a branching strategy in the git flow fashion or git flow style. Now once you have this kind of process, then normally what you do is you take feature branches, feature one, feature two, whatever, and then you make those changes. The moment you are done with those changes, you always put those changes back to the branch like develop, right? If feature one is done, you create a pull request this like this. So whenever your merge is happening, you are supposed to create a request kind of thing, which we call as a pull request. And what happens there is that the moment any changes that you want to put, you have to create these kind of pull request kind of pull request settings. And we will talk about what exactly these pull request talks about, what are the things you should think about, and all those things. But the point of focus over here is that whenever any merge is happening, it should always go through a pull request process. It should not go directly into the branch, a specific branch, develop or master or release. If at all you're working in a collaborative method, if you're working in isolation, that's fine. You can have your own way of handling these changes. Let's clear this thing. And this is the way this pull request goes. And this is once you are done with your work, you can tag this. We will talk about tag, what exactly tag is. You can tag the version which has been released, and then this can go in, and similarly this process can follow on. So this is the way, this is the flow of following the changes into the git. This is something you should follow in combination to fork, clone. So if you're talking about GitHub, you first fork it from some Microsoft /.net, something like that. Suppose you want to make changes into .net code, or you want to have a source code of .net and want to have a copy of it, you do the fork there. Once you have forked, you clone it on your local computer, and then you go with this particular process, so that you can, whenever you want to make changes into in this actual code, you go through a particular pull request process. And this is the entire flow of branching strategy, as well as git flow, the way code flows in git. All right, so let's go to the next slide, which is talking about git pull request in detail. So we again come to the same kind of diagram, and we will be focusing our discussion on the pull request. Now when you do the similar kind of work, you come from master, go to the develop, you create a feature branch, you make changes. All right, then you want to merge changes, you create a pull request. When you create a pull request, this kind of screen may come up. There you can, when you create a pull request, what happens is that the first thing you need to do is code review. So whenever you create some changes, so suppose in the code, let's go to this. So in the code, it was written A, B, and C. Okay, now you, as a part of feature one, you added D over there. So now it becomes A, B, C, D. Now this extra D will be visible in this pull request, and then whosoever is assigned to this pull request will be able to review whether D is a appropriate change that needs to go there or not. So this is one of the very fundamental thing, because of which you need a pull request process, or so that whenever some changes are going, those changes can be reviewed, those changes can be verified if those changes are expected to be there or not. Similarly, with GitHub and with Azure DevOps pipeline as well, if we will be talking about CI things in next upcoming session, that we have continuous integration. CI stands for continuous integration, and if you have joined our previous session, we discussed uh, a discussion on what exactly integration means, continuous integration means in brief. And then we will be having a dedicated session for continuous integration as well. Now what do we mean by CI checks is that if at all this D is going there, all right, and to build this A, B, and C, and whatever the test needs to be passed. Okay, so normally what you have is, in any code, suppose A, B, and C is written, I'm just giving example over here. It can be any actual code in C# or .NET, or maybe ARM template, JSON template, for instance, for creating infrastructure as well. So if you have a code, you must go through some process to validate whether this code is correct or not. So you go with the testing process. All right, you do some compiling in case of compiled language like C#, .NET. All right, you do some other testing and all this process is called CI if you are doing it continuously. If whenever the some change is there, you have the you have the options. And how do you implement it, we will definitely talk about during the continuous integration process. But using pull request, it is possible to run your CI checks. It is possible to validate whether this extra D is going to run along with A, B, and C for the existing test, for the existing process of compile, and any other process that needs to be taken care during the building the code, or during the compilation of this code, or during the automated or unit testing of this particular code. And this is what we mean by CI check. Now the next thing is merge conditions. Let me clear this up to make it visible. So the next thing that you do in pull request is merge conditions. So when you merge your code over there, okay, A, B, C, and then when you add a D over there, there might be some conditions. There are some types of merge that you might be allowing or you might not be allowing. So what do you mean by merge types? That whether you want to retain history of this particular feature update or not, whether you want to have a cumulative history, whether you want to have a kind of a same set of history that has been happened, or you just combine the history in one single commit over there. So there are different kind of merge. You can go there and just type merge types. You'll be able to see what are the different merge types. you know in your organization, suppose there are four merge types. All right, mostly there are four merge types. Suppose one, two, three, four. One of them is only applied to your in your organization. So you can apply some condition over there where they, if at all some developer is trying to merge the code using this second type of merge, where they can retain the code history, or they can retain the other things which is not recommended in your case, then you can do those condition checks in the pull request itself. So you do the code review, you do the CI checks, and you do the merge conditions. Now the next thing that you do is this static code analysis. Let me clear this thing again. So static code analysis is that whenever you run, you have some code, right? A, B, and C. All right. So whenever you have some code over there, and when you have a code, and you you might be running some static code analyzer, or there are certain tools there during our CI process itself. Many times you might run some static code analysis process where it will analyze this code, and we'll see that if at all certain code security or some kind of vulnerability is there, and they can report it back that okay, when you add D in certain way, all right, or if you add a class in certain way, or if you add a function in certain way, or if you are creating an infrastructure such as using ARM template or Ansible or Puppet or anything, if you are running it with so and so properties, if you are creating this infrastructure using so and so properties, there are certain things which are not recommended. This is what this static code analysis does. It goes through your code, it runs list of rules into those codes, and those list of rules are different from platform to platform. For C#.net they might be different, for Java they might be different, for ARM template they might be different, and there might be different types of tooling as well. Some types of tooling might support scanning Java files, but might not support scanning Python file, just an example. Or some type of tooling may help you to do some other things, like some of the major static code analyzers are Sonar Cube, Sonar Cloud, and all those tools. So those kind of checks or analysis you will be able to do during the continuous integration discussion. We will be definitely talking about these things in detail, but you can do all these kind of analysis during your code pull request process itself, and which will help you to maintain the healthy code in the develop or in the master. So if you will not do all these things during the merge, and if at all a user can able to add anything over here, a code, and will be able to merge things in the develop or in the master, what will happen? They might add certain things which are not meeting the requirement on in any on in any one of these what I will say points, like they might not be following the proper coding standard of your organization. They might not be able to confirm that, okay, this code, if I'm adding this code, extra function, extra class, if it will run the CI or not, continuous integration, if it will be able to build or not, if it will be able to run the test or not. They might not be able comply with the merge conditions that you have in the organization, or they might not be confirming the whatever the code is there, if it is secure, if it is up to date, if it does not have any vulnerability and all those kind of things. You might not be able to do so. That's why code pull request is a very important aspect of your merge process. Now let's go to the next point, where you can, other than this pull request, you can do or as part of this pull request itself, there are certain things you can apply based on the tooling that you use, that can protect your code. One of the major, the important thing is that your branch policy. So one of the these tools like GitHub or Azure repos provide you the way to provide some policy over there. So whenever someone is putting things on master, suppose this is a master branch, if someone is putting some merging into the master, they have to comply with policy. This policy can be pull request, all right, that they have to go with the pull request process. They have to go with certain they have to go with certain approvals. Okay, certain approvals from some people, manual approval. They have to comply with, it has to run a CI process, that if you are merging with master, the CI of master branch must be successful. Those kind of branch policy is you can configure, and that way you will be able to kind of protect your code for any unwanted code that may end up into your master branch or your main branch, and that may impact the security or the health of the code that is in the main branch. So that is one of the thing. Now the next thing is dependency graph. This is one of the feature of Azure GitHub, GitHub, in public GitHub, where you can have a option where you can enable a dependency graph. What it will do is, it will go into your repository. Like here I have a React material admin. Now here what it will do is, it will see all the dependent packages. All right, these are the packages which are which are a dependency for this particular code. And then it will see that whether these dependent packages has any update, or has any security vulnerability, or any kind of problems that I might have to see, or I might have to correct it before sharing it with other people. So this dependency graph can give me the dependency, what are the dependencies are there, how do should I update some particular package. So you can see this, what are the various packages I am using. This material UI I am using, this within material UI, this is using Babel, and then within Babel this is using this regenerator. All these version numbers are mentioned. If at all there are some version number upgrade, it will notify me, and then accordingly I can make my decision to upgrade those packages, to plan my package updates, so that if at all some package version has some issues, I will be aware of this particular thing, which is again helping me to maintain a very healthy code in GitHub. The next thing is dependency alert. Using the dependency graph itself, you can create, or you can enable, you can see this, you can enable dependency graph and dependency alert, which can help you to give the alerts to your email, that if at all some dependency is out of date, if there is some security vulnerability or anything that you need to be aware of, all these things will be given to you as an alert with the configured email ID that you have for your repository. So that way you can maintain the secure code for your version control system. The next thing is, but not the last, is very important thing, which is git ignore files. Now git ignore files are one of the way to maintain your code with when you create any code. For example, if you create something with Visual Studio, I have given example of Visual Studio. Some of the temporary files gets created like .su, just to make sure .suo .user, or some of the files like uh, maybe some bin a folder like bin folder where all the debug files are getting created. So all these folders normally are user specific or not, need not to be tracked in your version control, because they are very much specific to the to the machine where it has been generated. First thing. The second thing is that it does not need, I mean, it does not have any functionality aspect of the code. So code is still in your .cs file or something where you are creating your C sharp functions, C sharp classes and all those things. So these are the only files or associated files need to be tracked. But these are the few files that you might not want to track or you might not want to put into the version control system. All right. These files can be ignored. All right. These files can be ignored using a file named as git ignore. What is the file is that it has to be .git ignore. This is the the file name. It has to have an extension of .git ignore. When you create a file with this name, and if you mention the files like this, like star, if you want to do the wildcard search for a particular file type, you can do the star thing, or similarly, or a folder, or anything. Whatever you mention over here, it will be ignored from the git system, so it will not be tracked. And and that way, whenever you are putting your code into the version control system, it will not be pushed to your server, to the central server. And that is how your server will be free of, first of all, you will be able to save some space on the version control system, because some of the files like bin folder has sometime exe file as well in case of .NET applications, client application. These exe files are output files which are based on after the debugging process, which needs not to be maintained in the version control system. So some file space you are saving. The second thing is that some of the information where you have like user specific information, or you might have a file which contains some connection string or something like that, you can avoid sending those files to the version control system, so that if at all someone is looking to your version control in GitHub, they will not be seeing those secret, or those what I would say, the secure information or user specific data. Those things will be still on the local machine itself. Now, to manage the secure information like password or the connection string, there are different ways. We will be talking about that in a bit. But if at all your version control has some JSON file, some XML file, or some kind of files where some user information is stored, whether it is email ID or whether it is connection string, or it's just a username as well. For some organization, even the username itself is a very secure information. And it might happen that when you are creating some files using Visual Studio creates a file, a metadata kind of file, .suo or something like that, which contains your username information. How do you ignore those information? Using git ignore. This is another aspect of protecting your code. Now let's go to the next slide. uh, Okay, so let's go to the next slide to see the configure repository. Now we have discussed about what are the various things are available in the tool which can help you to adopt the version control system in your organization, using certain functionality, certain practices, and certain features which are available in GitHub or Azure repos that can enable you to protect your code, that can enable you to plan your merging and changes into the repository, changing into the code properly. That will help you to do the proper code review process before someone is sending the code to the version control system. So all those things are possible when you use Git version control system with all these most basic and yet the most important point, or the features. Now we are going to discuss about configuring the repository. Now this topic is going to talk about what are the few of the configurations that can help you to achieve certain things we just discussed about, that who can do the changes, who cannot do the changes, all those kind of things. Let's see that. The first screen we are talking about is repository permission. So if you are using Azure repos or any other system as well, there must be a way to control the permissions, which is a very important aspect of your version control system. So version control system, for instance, here I have I have opened the the version control system of one of the project in my organization in Azure repo. And there, if I see the permission option, I can see that there are certain groups. All right, these are the groups that you have in Azure DevOps. Which group can do what? Like I have this project collection administrator, and I can set up a policy, a permission where I can say that bypass policy when completing pull request. So I can say that if someone is part of this project collaboration administrator, or I can search some users here as well, individual user, and I can set that this particular user, or this particular, any user who is part of this group can bypass the policy. So whatever the policy I am going to set up, that you must go through a pull request process, or you must go through a CI check, you must go through all those kind of things. So I can configure who can bypass and who cannot bypass. Similarly, I can give a very fine grained role based access control, like who can create a branch, who can create repository, who can contribute, like push the changes, who can edit the policy, who can do the the other aspect of a version control system. All these things are possible using permission option, and you can definitely go ahead and configure it. It is a very important aspect of using Git version control system in your organization. There will be certain people for whom you want to bypass the policy, but there might be certain people to whom you don't want give access to create repository. Like for instance, here I am allowing this administrator to create repository, but I might not allow the part of this people, build administrator or contributor or project administrator or reader, anyone. Like I might be able to change this permission, whether they should be able to create a repository or not, or a particular user as well. This is, we are talking about grip, but you can also search an individual user, and you can you can control all these kind of permissions for them as well, and which helps you to kind of protect your code from unwanted changes by someone who is not supposed to do those changes. All right, so let's go to the next thing, which is important from the repository configuration point of view, which is git tag. Now what exactly git tag is? We just talked about git tag in one of the previous session. Let's go ahead and see that what happens here is that when you have a version control system like this. All right, normally what happens is that whenever you have some changes, you create a pull request. Fine, based on the pull request approval, you again go ahead and create a pull request to the master. And then once you have this thing in master, all right, once you have this thing in master, to track the specific what I would say specific point of change, like what is the state of code here when someone merged it. All right, that for that we can create something called tag. The syntax is git tag. All right, there is a way to create git tag from the screen, from the web interface, or from the command line as well. You can create tag. What happens is when you create a tag, whatever the source, whatever the state of the code is here, it will be it will be saved as a kind of a pointed version like 1.0. Now you can any point of time you can go to this tag, you can take out the code, you can you can see what was released as part of 1.0, whether I want to do some changes or not, can I restore the code on this level or not. So this is again a kind of a specific point in code history. So when code is being merged, and if you think that you want to just make a kind of a pointer here, so that future, if at all you want to know that what was released as a part of 1.0, you do not have to go deep down into the history where what user done, what user has done the changes, what was the feature one, the release point 1.0 features which was released, so that we can track the changes, who did it, what. You can simply go to this particular tag and you can see that what was done in this particular change, and that way it gives you a single point of reference that can be used in future. Now once you create a tag, now this tag is saved, you can definitely go ahead and make create further branches from here. Definitely you can do that, but in this tag you cannot amend the code, unlike here. So when we take a we when we created a branch from develop, we make those changes and then we were able to merge these changes into the same branch. But tag 1.0 once created, it will not be able to modify. Whenever you want, if you have done some changes over here, you will have to create another tag, maybe 1.1 or 1.2 or whatever, based on that. So this is this is one of the major difference between branch and the tag. That branch, you can keep on taking from latest branch, you can keep on merging changes into the branch, but in tag you cannot merge changes. You take the latest, you take the code from the branch, from the tag, you do some amendment and you create another tag. So just to make sure, or kind of track the changes that you have done from 1.0 to 1.1 or something like that. This is the way this tracking works in the tagging world. Now let's clean this up. Okay, and then you usually use with version number. Normally you create a tag for release. All right, so whenever you want to create a release, you normally create a tag, and then similarly, once you create a tag, you can manage that particular tag number, and based on that only many people segregate the code, right? You have a code version number 1.0. Someone says that okay, whatever you released as part of 1.0, there was a hot fix, or there is a problem. So you take that particular 1.0, look at it, what are the things are there, and you simply go ahead and make those amendment, and you say that 1.1 is released, you go ahead and build a solution out of it and then use it. Yeah, I can control whether I want to make these 1.1 changes available into the master, or just I want to make it available within the 1.1 only. Those kind of conditions are the, I mean, those kind of decisions I can make. But this is the way tags are used, and this is the way tags can help you to kind of retain a particular point of code change in your repository. Now the next thing is merge restriction. Of course we have discussed about that. Whenever you create a merge, you have to have certain policies, right? That if someone is, suppose someone is master, someone has taken a code from master, and if he wants to merge with those, suppose he has added a plus b plus c, something like that, and then he wants to make it available in here, then he has to go through some policy. He has to go through those condition, whether you have the permission, yes, whether you have a proper approval, yes, does it pass the CI checks, yes, does it pass the the other manual approval needed, yes, all any other policy that you have configured. So make use of branch policy to make the merge restriction possible. The next thing is this pull request guidelines. Let me go ahead. Okay, with tools like GitHub, you have a way to create pull request template. So you can create pull request template, so that whenever someone is creating a pull request, it will create a kind of a form where they need to check marks, like okay, this has been checked, this has been checked, okay, code is up to date, code is running, the CI pipeline code has up to date, code is following certain guidelines in terms of coding standard. All those things are configured, can be configured, and can be passed on as a guideline, and that way anyone sending any code to another branch, he will be only able to send those things if he is passing all these guidelines. So make use of pull request guidelines, which is possible either using GitHub, okay, with GitHub or Azure repos. Both gives you option to configure your GitHub guide, pull request guidelines, so that you can confirm, you can configure who can do what. And yeah, whether they are passing all those things, they have to explicitly check those things, whether the CI pipeline is running, whether the code is following certain nomenclature or naming convention, or the syntax highlighting, or any kind of guidelines you can have in your internal organization or for your software. Now the next thing is that approvals, right? Just like this, once you have your pull request guidelines, you must configure your approval selectively, that those people who are responsible for, suppose, so how it works is, normally, suppose this is your develop branch. All right, this is your develop branch. This is your develop branch. Now someone has taken code from here and he wants to merge back changes here. Now this develop branch must be owned by some team, or some person or some team manager. Like suppose this is owned by engineering, okay, in the organization. Now when these changes are going, so a responsible person, a stakeholder from this particular team must be getting a approval request, that boss, you need to approve it, because someone is sending those changes into something which is owned by us. This is the way it works in internal organization. Or it can be open source, open source software way as well. That suppose you are maintaining a code on open source. All right, let's, yeah, so suppose you are maintaining a code on open source system, on a GitHub repository. You are the maintainer. All right, you are the maintainer. And if someone fork your app, application code, they have added some feature A, and then they want to merge it back to your actual code. All right, now during this process a pull request must go to you. All right, it must go to you only. And then because you are the maintainer, if something goes wrong, then your application is going to be impacted. And these kind of approvals, or who should be approval, that needs to be decided properly, so that it does not become a normal bureaucratic process only, where approvals is given by someone who doesn't know what is going and what is not going. It has to be some stakeholders which are supposed to do the review properly, rigorously, and see, be able to improve this process as well. They should be able to see that, okay, in this pull request guideline you have included one, two, three things, but you have not included a fourth thing which we usually check. Can you please include it as an automated test, or as an automated check? So these kind of improvement can come from those people who are actual stakeholders. So you need to configure your approval properly, and this is the way you can improve your code merge restrictions, or improve your code merging process. With this, we have kind of discussed various aspects. Like uh, first of all, we have discussed that you have something like Git. All right, once you have the Git version control, what are the various benefits you get with Git version control? Like you have this distributed version control, right? So you have this distributed version control. What is the benefits of having a distributed version control? Because you can have a computer, you can clone this on your laptop, you can keep on working. All right, you don't really have to have a online connection between your server, your remote server, you call it. All right, you can work from home, you can have work from a computer which is not connected to the on-prem, sorry, the network. And when you want to push your changes, you will need network connection. That time, of course, you will need it. Then we discussed about how do you manage this flow. Like what are the you do the fork. All right, from fork you do the clone process to make it available on your laptop. All right, now once you have it on laptop, how do you need to do manage the code using branches. All right, we have discussed about branches. Once you have the branches, how do you manage these multiple branches, like master branch? All right, your develop branch. All right, and your feature branch. How do you make use of feature branch? And we discussed about how do you make use of pull request to merge changes from one feature branch to develop, or from develop to master. And then we discussed about the tagging process, that how do you tag your process code to particular to actually save a particular to save state of code at a particular time. That's how you can make use of Git in a better way, so that you are using all the basic functionality of Git, whether you are using GitHub or you are using Azure repos, and then you can make use of all these features of managing the version control system, as well as allow following the best practices such as pull request system, such as branching strategy, such as permission control, or merge restrictions or branch policies, so that your code is protected, your code is anything that goes into your code is reviewed properly using pull request system. You have your proper configuration of your approval system. Whosoever is sending the code is has been properly approved by relevant stakeholders. So these are the this is how the whole journey goes through. Now the last topic that we are going to talk about is integrate source control system. Now once you have the Git, all right, once you have the Git system, okay, uh fine, you have the code, fine. Now once you have the code and you have configured it properly, you have managed the whole life cycle, how the code changes will happen, how the code changes will come to your laptop, what are the merging guidelines that you will be following, who is going to approve the changes and all. Once code is there, all right, let me clear this there. So once you have done your changes into your Git, once you have, once you are able to successfully put those changes on the Git version control, then you can have a trigger. This represents a trigger which can enable continuous integration. So what do you mean by continuous integration? As soon as there is a change in code, there will be a trigger. What it will do is it will start a build system. It will start a build system, or we call it CI system. All right. What it will do is that CI system will, as part of this CI system or build system, it will run certain things like, it may run some test. All right, it may run some build process, it may run some compilation process and all those things, and it will generate a report for it, that whatever the changes has happened during the code change process, after proper approval, after proper check-in, everything is done, the code build system is running it, and then it gives you a kind of a report that whether it is green or red, whether it is failing or passing, and based on that the code can continue further. What it will do, we will just talk about it in a bit, but this is how it happens. Now when you talk about these CI system, all right, or build system, there are various options you have. Let me clear this slide. So there are various options you have. Some of these options we have outlined on the slide. That one of the thing that is coming from Microsoft is Azure pipelines. One of the other thing again from Microsoft now, which is part of the GitHub ecosystem, which is GitHub Actions workflow, which is again we are going to talk about in a bit. This is again one of the CI pipeline system which can ensure to run your code through these processes, build process, test process, and whatever the processes you can have during the build process, so that you can confirm that whatever the changes has been done is able to build a usable, what we call is artifact. We call this artifact that, once you build, once you are able to pass this build system, once it is green, then it will create an artifact. What do we mean by artifact? These artifacts are nothing but usable things in various platforms. It can be a Microsoft .NET application, exe file, msa file, or anything that can be considered as a Microsoft .NET application output, which can be hosted somewhere, which can be used, which can be consumed. The actual word is, the artifact is a thing which can be consumed by the server or a system. So you can have a Node.js output, we can have a Python output which can be used. So once you develop your thing, once you gone through the testing, once you go through the compilation, if at all it is a .NET code or something where compilation is supposed to take care, then it will generate something. Okay, and this something is called artifact, which is consumable artifact, means that it can be directly used to deploy. After this, you will go to the release process. We'll talk about release process in a bit. I mean, in a release process mod discussion. But here, what we are trying to tell is that once you have the code, you run some checks using these tools to make sure that code is building something which is supposed to be builded. And that can be some of the examples we have given is .NET, Node.js, Python, Java, or as simple as that, a normal zip file as well. It can have a normal zip file. The artifact coming out of this system is a normal zip file that can be deployed to a server using some zip deploy method or something which can be further consumed. Now, after this particular process, whatever is coming as an artifact is not supposed to be changed from the code point of view. So whatever changes supposed to happen on the code level, it will happen here. And if at all it is going through this, and if at all you want to make sure what you want to make sure is that whatever your CI system is giving output, that does not include further changes into your code. If at all your process has certain things where you are getting .NET code and then you are your manual or automatic, you are going through the code and making some changes into the web.config or maybe into the CS file or maybe some XML file or whatever, then your artifact is not a true artifact. I would say it is still making changes on the source code level. And if you are making changes on the source code level, that means you are not taking care of things which supposed to happen here and here. Anything that needs to be taken care on the this level should be taken care on the code level. If at all there are certain generic code changes, suppose you need to replace your connection string, you need to replace certain developer specific connection string, or you need to replace certain code which is a dummy information, then that should happen as part of the build process itself. Once the output is coming out of the system, this should not be updated by any system, whether it is manual or it is automated. It should be consumable. It should be given to a particular system or a manual process with the proper guidelines that this is the way you can make use of this artifact, whether it is .NET application, Node.js or whatever, and then they can be able to make use of it by deploying it on a server or by deploying it on their computer or whatever. So this is the way CI system works. Now, to implement this kind of code change system, you have various options there. Let me clear this. One thing is that GitHub Actions workflow. This is one of the very what I would say popular CI system these days, which is coming again from Microsoft as a part of GitHub offering, because GitHub is part of Microsoft organizations now. This particular workflow, what happens from your source code app, from your source code repository itself, it gives you a way to create a workflow. When you create a workflow, what happens is it gives you a way to create a pipeline using a YAML file. All right, using YAML file you can create your pipeline, and that pipeline will tell what's supposed to happen as part of this particular build process. What are the things that needs to be taken care? As you can see here, you are using make use Node.js, you are setting up Node.js, then you are doing some version control system, then you are running some node npm command lines over here. So these things you can you can see that you are running some npm ci, npm run build. So whatever the steps that needs to be taken care, all right, that can be that can be done by using this workflow system that you have. And this is the way you can go ahead and configure your pipeline as a code. Nowadays this particular thing is coming into picture, where how do you configure this whole workflow using pipeline? Previously, or even today, as of today in Azure DevOps, we will be talking about that option in a bit. There is a way to create this whole process using a visual editor, using a graphical user interface. But in GitHub, you get an option where you can create a pipeline as a code using a YAML format. And what benefit you get is that just like you define your infrastructure, or application like a code, you can define your pipeline as a code as well, and you can automate this entire process going further. So later on, if at all certain type of application are built frequently, or certain type of applications needs CI pipeline in your organization frequently, then if you are using pipeline as a code, then you can actually build this entire script automatically based on the, based on your need and all. And then what will happen, you can have this again further automation on top of automation. So you are already doing automation if you are configuring pipeline. Now you can have automation which can take care of configuring pipeline as well, as a part of automation. So this is the reason this pipeline as a code is becoming famous, and this is the reason GitHub or Azure pipelines are stressing a lot on the option where they can give you an option where you can create pipeline as a code using YAML format. There are certain other tools like Git, Jenkins and other CI pipeline tools, which gives you another way of creating pipeline as code. Syntax may differ, but the whole logic or the concept behind having pipeline as code is the same one. Let me clear this slide before going to the next point. Okay, so now we go to the next point is automate review. Now what happens when you create your pipeline, and if you are, if you are making use of this pipeline as code, then what is happening is here you can see this. I am configuring pull request. Whenever there is a pull request being raised for this branch, master branch, I'm going to run this pipeline as well. So that way I can make sure whenever there is a pull request happening on the master branch, this pipeline will run, and the pull request approver who is going to approve the pull request for this particular branch will have the visibility that whether this pipeline is running or not, whether this pipeline that has been configured for master branch is running or not, if these changes are being merged. So this is the way you can automate your, entire process of pull request using the pipeline as code option itself. And that is how GitHub Actions help you to automate the pipeline, what I would say, pipeline as code, as well as CI continuous integration process to build your code to, kind of visualize this particular entire workflow. Now coming back to this GitHub, let's go to the next option that we have is another offering or another software that is or SaaS offering from Microsoft, that is Azure Pipeline. Azure Pipeline, from the functionality point of view, also gives you a similar set of features, but of course, because it's a different tools altogether, the interface may differ and the few of the features may differ, but it is also one of the tools that you can use to configure your pipeline for any type of platform that using your pipelines in the Azure pipelines. For pipeline means that your CI. When we say pipeline, this is the process we mean by pipeline. So you can define this pipeline using using either Azure GitHub Actions workflow, or you can define the same kind of pipeline using pipelines, Azure pipelines. The product name itself is an Azure pipeline. Now using Azure pipeline, you can, as you can see from the web interface, you can directly go there and click on new pipeline. Using new pipeline, you get both the options. You can either go for the graphical user interface or with the YAML approach. When we say YAML, of course the syntax is same, YAML syntax is same, but the language or the command or the structure is different for Azure pipeline and GitHub. So GitHub Actions support a different thing, and this Azure pipelines supports different thing. The structure will be same. When you create a pipeline in Azure pipeline, the structure looks similar, but the options you get, the terms that you are going to use in Azure pipeline will be different than the GitHub Actions. They both use the same standard, that is YAML for defining the pipelines as code. Now the next thing is that just like GitHub Actions, you can configure your build as well as release. So this Azure pipelines will help you to run the CI as well as CD. Okay, so when we will configure, when we will be doing the labs as well as in our upcoming sessions, when we will be talking about continuous integration and continuous deployment, we will see that how you can configure Azure DevOps to do this continuous integration as well as continuous deployment. So it helps you to do the end-to-end deployment process, end-to-end integration as well as deployment. And when you combine it with Azure repos, which is where when you combine it with Azure repos, which is a Git offering, so it becomes a complete end-to-end flow. Like just like Azure repos plus pipeline, Azure pipeline, oops, becomes a end-to-end tool for your version control as well as your pipelines need. And the similar way, GitHub plus GitHub Action becomes a similar kind of alternative for you. It is up to you which one you want to go with. You want to go with this combination or you want to go with this combination. And also there is a crisscross combination also available, where you can use Azure pipelines as your pipeline tool, like CI tool, and GitHub as a version control, or vice versa. You can use Azure repos as your version control, and GitHub Actions, GitHub Action, I think, do not support Azure repos. Yes, so this crisscross connection is supported. You can have your code in GitHub, and you can use Azure pipelines to run the CI pipeline, to run the continuous integration. Let me clear this. Okay, now another major aspect of Azure DevOps is that Azure DevOps, from the feature point of view, not just support what is supported by Microsoft. So what is supported, what is given by Microsoft in the tool, it's fine, but Microsoft has also a marketplace kind of thing, just like you have a Play Store in Android, or iStore in Apple. Similar kind of Play Store, marketplace is available in Azure DevOps as well, where you can search a various third-party tools integration. The various third-party tools like Chef, Puppet, Ansible, Terraform, all these third-party companies as well as individuals publish extension for extending Azure DevOps with other third-party tooling system. So that way, Azure Pipelines becomes a very, very differentiated product from other market competitor. It is very easy to extend Azure DevOps with any popular tool that is there in the market. So most of the things are available, but suppose you have Azure repos, okay, Azure repos for Git, okay, but you might not like Azure pipelines for your for your you might not like, or maybe you might not be able to plan the migration of your CI system to Azure pipeline, and you might be using Jenkins at the time. Jenkins is one of the popular tool for CI running the CI workloads. So what happens, you can integrate Azure repos with Jenkins. So whenever some changes is happening on Azure repo side, it will run the CI pipeline or the build pipeline on the Jenkins, and that way the kind of integration this particular tool gives you, it is very much very smooth and easy to set up with many of the industry standard tools like Jenkins or any other tools that you have for deployment as well as build pipeline or deployment or artifact storing the artifact. So those kind of integration is possible using Azure pipelines. Let's clear this thing. Yep. Now let's go ahead and talk about configure single sign-on. Normally, organizations will use Azure Active Directory for configuring the authentication majorly they use Microsoft Azure, or what they use, like, gosh, or Office 365, or any other tool they are using. They might be already using this Azure Active Directory. This is called Azure Active Directory, or AAD. They might be using for authentication. Now, if your organization is one of the organization which is already using AAD for user authentication, then if you are planning to use any one of them, either Azure DevOps, which is Azure Repo, all right, we are talking about, which is part of this, or any other tool there as well. We will be talking about those in upcoming sessions. Or you are using another tool like GitHub. they both support this single sign-on feature, just like they support with Azure O365 or other services that is being supported by Azure AD. So you can configure your Azure AD for having a single sign-on functionality or controlling the user identity to access to any of these systems. And it is very this makes this actually makes a very smooth transition for enterprise customer for using Azure DevOps in their existing environment if they are already using Azure AD for accessing any one of the environment they have, mostly Azure, Microsoft Azure and O365. They definitely be using Azure AD. Having said that, Azure AD can be configured with other third-party systems as well. So similarly, Azure DevOps and GitHub gives you a way to configure Azure AD for authenticating with for authenticating with user. And when you set up this thing, this becomes a very simple thing to manage all types of users, service account or authentication or permissions in single place on the Azure AD level itself. You don't have to manage a different system for giving access to GitHub or Azure DevOps. GitHub Enterprise here you are talking about, or GitHub Public. Okay, so this is how you can configure your Azure AD system. When you make use of this Azure AD system, and when you do the deployment to one of the platform, uh, infrastructure as code becomes a need of the time right now. That earlier, most of the people who are working with version control system will be developer most of the time. Previously, like developer will work on some technology like C# or something, they will create application. This application will be part of some build system, CI system. This CI system will generate something, this will be deployed on a server, and then user is accessing this server. Fine, this is how the development ecosystem worked. Now the similar kind of need is coming here as part of, suppose this is ARM template, all right, or any other infrastructure as code tool like Terraform or something. Now infra guy will be following similar kind of system, where his code changes will be going through some CI system, all right, will validate the code whether the code is fine or not, then that will deploy the server, then this deploy server will be used by the development ecosystem, all right, and then the deployment will happen. And then this way this dev and infra are working together to make things possible. Whenever there is a code change happening, that the server which is there is up to date to make sure whatever the changes are coming is the server is capable enough to take up those changes. Yeah, and if at all something is needed to be scaled, it is up there. And that is how this whole system of DevOps, all right, is coming to picture. Developer with operation system which is using infra as code concept. And this is how this GitOps kind of terminology is coming into picture. So what do we mean by GitOps is that when you clear the, let's be clear. Yeah. So what do you mean by GitOps is that whenever some changes happen, used to happen, either configuration or infra. Okay, any deployment supposed to happen, it will happen using Git, all right. So it will not happen through manual intervention and all. As and when there will be a change, there will be a build system which is able to visualize the code changes, if at all it is for auto scaling, or if it is for highly availability, or it is for automated deployment. The since this is whole automated in based on code, we will be able to see that how much infrastructure is being used, if at all there is some auto scale need, if at all some users need access, those access will be defined by configuration itself. And then the deployment will happen on the server. And then whenever the server is increasing or the use is increasing, the automated telemetry is available. And that based on the telemetry, you can automate the auto scale process. And that way the whole process of GitOps becomes a reality, that whenever changes are happening using the code only, it is not happening via some version, some other system. So this is the way you can implement GitOps and infrastructure as code. There are various tools and technology available from the Azure or Microsoft point of view, or from the industry point of view as well. So you have this ARM template, right? You have this Terraform or other tools as well, Puppet or all other things. So using which you can implement the GitOps model where whatever changes supposed to happen into your infrastructure, which will happen using Git. Okay, so let's clear this thing. And let's go to the next thing, which is continuous deployment. Now, when we talk about continuous deployment, we talk about GitHub Actions. Definitely, the GitHub action, just like we did the the code changes process. You have a code change, you go through a CI system, and then you have the artifacts, zip or exe or whatever, or MSI, whatever. And then, using the GitHub action itself, this MSI can be sent to the server where it can be deployed. Now, again, here, deployment to the server again can having a GitOps model where this is being taken care by Terraform or ARM template, right? Fine. So this is the way you can control this whole thing. Now, similar kind of workflow can be used by using Azure pipelines as well. Azure pipelines also helps you to implement certain kind of this kind of this kind of workflow where whenever there is a code change, CI will run to make sure code is valid, code is tested, all the unit tests are passing, all the compilation is happening properly, any code analysis supposed to happen, it is happening properly, the code is secure and all those things are fine. Then it will generate the artifact, and then the similar kind of infrastructure as code implementation using GitOps methodology can be applied using Azure pipelines as well. These both tools support this kind of workflow. When you use any of them, GitHub Actions or Azure pipelines, and if your code contains some secret information, right? So it may happen that your code does have some service principal ID to access some API, or it may happen that your code does have some connection string, or all those things. You may make use of Azure Key Vault, all right, in case of Azure pipelines or GitHub, to store your secret information over there, and then during your pipeline execution here, you can fetch those information securely, and then you can use them into the CI pipeline. So this Azure Key Vault integration is possible using Azure pipelines. Similarly, GitHub has something called secrets, so you can create secrets over there. These are these are they will not be exposed to either CI pipeline, while CI is running. Any debug information will not have those things which you have mentioned through secret, and it will be possible for you to fetch those information during the CI pipeline run. When the pipeline is running, it will be possible for you to fetch those password or fetch those connection string or fetch those secret values, and then make use of it during the execution of pipeline, and then just go away with it, and then make sure things are happening as expected. Now later on, when someone looks at those logs, they will not be able to see the plain text information there. But if you are managing password in the code itself, it is not secure, because first of all, anyone who can see the version control system like Git, if you are posting it on GitHub public, anyone who can access this particular repository, they will be able to see those information in the code itself. Even if you are not and then if you're not using the tools like Azure Key Vaults and secrets, it will be very difficult for you to manage that code in a very secure manner. So that is why during, and then this particular information becomes very important during the continuous deployment, because during the deployment it might happen that you might want to change the connection string, right, the database connection string, or you might want to access a particular API or a particular you might want to access Azure to deploy the server. You might want to access certain other cloud system to deploy certain resources which is needed for deployment process. All those secret information should be stored in these two system. Now, next topic is ChatOps. Now, what exactly ChatOps is? Just like GitOps, right? So you have this, this thing, this version control system, which is called Git, where whenever some infrastructure change is supposed to happen, you say that you are going to do with infra as code. All right, and then some CI pipeline will run. All right, and then it will deploy the server so that application code, app code, which is using again some Git system, again going through a CI pipeline and then can be deployed to the server. Now this is what we talked about GitOps. Now, what exactly the ChatOps is? ChatOps means that there are certain tools like Microsoft Teams, which can help you to see the continuous update from your pipeline. So some pipeline is running, you can directly go to your MS team and can see what pipeline is going green, what pipelines are going red, who ran the pipeline, who is, or what changes has been done by someone which is running the pipeline. So all those kind of things can be done in a very chat based scenario, event based scenario, that something happened, something will be available on the other screen, maybe it is MS team. Similarly, if at all you have a different system altogether, you don't have a MS team, right? You have some web app, some portal where some information, some event supposed to be posted. Suppose some developer, let's clean this out, some developer has made some changes. Okay, some developer had made some changes. Now these changes are, you need to make sure this particular portal, internal portal, okay, should be able to visualize those changes. Now this can be possible using this GitHub webhooks. You can subscribe to this webhook using some developer based technologies, and then whenever some event is happening for which you have subscribed, that event will be registered over here and it will be visible. Now this can be an internal portal, this can be a tool like Jenkins. Suppose you have Jenkins, okay, you have Jenkins system. Now you have configured Jenkins. Whenever some code is being published or pushed, okay, you supposed to do 1 2 3 whatever, like you're supposed to build the server, you're supposed to build the send a message to so email address, you're supposed to do do some CI pipeline or whatever. These things will be possible using GitHub. Similar kind of thing, if at all you don't want to do a kind of a event based driven thing, here in GitHub webhook, what is happening is that anything happens over here, I will be notified with that information over here. Now if at all you don't want this event kind of thing, event based notification, you then there is something else called polling. Now what polling does is that my system, Jenkins or any other system or a custom solution, will keep on polling the system, the GitHub or Azure repo, and keep on looking, oh, is it there any change, do you have any change? If at all you have some changes, I'm going to run this 1 2 3 whatever I have configured. I want to run a pipeline, I want to send a message to some people, I want to create a branch, I want to do whatever they want to do with this particular system. So they can either poll, okay, or they can have a subscription based model where they are subscribed to this webhooks, okay, and they are getting the updates as and when events are happening. Or they can poll in on the frequently level, 1 minute, 1 hour, 1 day, and then based on the polling, whatever the changes are there, they are taking uh, those changes, and based on those configuration or based on those changes, whatever decision has to be taken, whether an email supposed to be sent, or whether some infrastructure supposed to be built, or whether a release supposed to be created, or whether a build supposed to be created, whatever it is supposed to be created, this system, Jenkins or any other third party tool, will be take care using this particular GitHub apps, or this particular model. Similarly, Microsoft Teams also has a very nice support with Azure pipeline or Azure repo. Actually, Azure repo, whenever you make some changes, there is a connector. Okay, in previous session also we have shown that if you create a connection between Azure repo and MS Team, anything happens on the Azure repo will be available in the MS Team channel, and that way you can keep on updated using a ChatOps model. You can be having a chat kind of information, you can have configured that if I will run this, this will happen, and that kind of methodology is possible. And that is how the ChatOps model is possible, either using GitHub apps which provides you two ways of communication, whether it is webhook level, which is event based notification system, or can be polling level, which is keep on polling on the frequently time, and then it will come back to the it will take action based on the polling information that it gets. Similar to this, you have Microsoft Team integration with Azure repos, which can give you a way to connect to Azure repos, keep on scanning whatever changes are happening, and it will be available in the MS Team. Now, having said that, I think we are done for this particular module, and we will take a short break. And then after break, we are going to have a demonstration by Nitanshu, who is going to demonstrate the complete Git system, doing some way most commonly used operations. And then we will then after that we'll be having a quiz, as well as we'll be announcing the winner of the quiz from the previous session. So for today's quiz, we will be just having the quiz, and then we will be announcing the winner in the next session. But in this session, we'll be announcing the winner for the previous session. So if you have participated in the previous session, please be connected. We are going to, announce the winner, and probably you are one of them who is going to get a free Azure voucher, using which you can give any exam from the Microsoft free of cost. So let's take a 5 minutes, 10 minutes break, and then we will come back to for the demonstration. All right. Okay. Nitanshu, you there?
Yeah, I'm here, Ashish. Thanks,
Yeah.
Ashish. So, welcome back, guys. This is Nitanshu. I'll walk you through the demonstration today. So, in today's demo, we will be covering version control in Visual Studio Code and Azure DevOps. So, we'll be completing few tasks in this exercise to achieve our motive. So, first of all, as you
Nitanshu,
know,
Nitanshu, can
Mhm.
you please share your screen?
Yeah, just a second. I'll check. Are you able to see my screen?
Uh, yes.
Yeah.
Yes, please go ahead.
So now as you all know that Azure DevOps supports basically two types of version control. One is Team Foundation version control, and another one is Git. So now Git is basically a default version control provider in most of the Azure DevOps projects. So it is a distributed version control system which can live locally as well as remotely, and same will be achieving in this demo, that we'll create a repository locally and then try to sync it with the central repository in Azure DevOps. So for that, I have already installed Git and Visual Studio Code on my system. So first, uh, we will just set up some credentials which this Visual Studio Code will be using while committing the changes to the remote repository. So first, just let us just set up the credentials. So for that, we have some Git commands. So we'll just type in those commands. Okay, config space global space credential dot helper with grid. Then in the next command, I'll just pass my name and email ID one on one. And then I'll just pass the email in this one. Explorer.in. So with this, we have set up our credentials. So these credentials will be used while committing our changes to the remote repository. So in the next part, we'll just try to clone an existing repository. So for that, I have already have a DevOps project created in which I have some source code files from .NET files and some. It is basically a full project. So for that, I have created a repository with this name called parts unlimited. So we'll just try to clone this repository on our local. So we'll just go on to this repository and we'll click on clone. So and we'll just copy the URL from here. We'll go back to our Visual Studio and there uh, we'll press we'll just press Control Shift and P on our keyboard and it will open a Git command console where we can type all our Git commands. So here I'll type Git and it will start giving me some suggestions. So I'll just click on Git clone and as soon as I press enter, it asks me to provide the URL of the repository. So I'll just paste the URL that I have copied earlier and I'll click on enter. So now it is giving me a pop-up to select the local location on which I want to create the local repository. I'll just go into the C drive and create a folder here, name Git. You can keep it name as per your choice, and I'll select the select repository location. So here it has started cloning the repository. So all the uh, content that is there in the remote repository will get synchronized with our local repository as of now. So it is asking me for credentials. So I'll just pass in the username and password for my account. And we'll just wait for it to get completed. So it get completed, we'll click on open. So there you can see this repository is our local repository, which is the copy of one of our repository in the Azure DevOps portal. Now the next in the next part we'll try to just commit some changes into our local as well as our remote repository. So we will just go into one of the source files. So this is basically a .NET file, the .NET code file. So there I'll just add on a comment here saying my first change, and I'll just save it. So as soon as I save it, this source control button is showing me notification 1. So it has identified that I have made some changes. So commit basically contains two things. One is the change that you have made, and another one is the message. The message is basically for letting you know that what kind of changes you are making into this commit. So I'll just type first change, and then I will click on this right mark. So it says commit, so I'll click on just commit. So and then click on always. So this has as soon as I click on commit, so this has reflected the change in my local repository. Now when as I want to make this change to my remote repository in Azure DevOps, I have to synchronize these two repositories. So for that, we'll just come down and click on this refresh button, which will push my commits to the remote repository. So I'll click on just OK. So as soon as it got completed, we'll go back to our project and see if the commit is there or not. So in the commits, you can see there is it is showing me the first change that it is the same message that we have typed there in the commit while doing the commit, and it is showing me that this commit has been made. Then what we can do is we can review our commits as well. What kind of commit was that? What changes were made? So when we click on that commit, it will open us the exact changes. It will show us the lines of the code that we have made the changes in. Now on the for the next second exercise, what we'll do is so
Now here,
sometimes.
Nitanshu, I want to stop you just for a minute.
Yeah,
So now
go ahead.
here you see that, how Nitanshu has taken a repository from a Git repository that is in the Azure DevOps and Azure repo, and then he has made some changes and then he published into Git. Now he is doing directly into the master branch right now. Now we discussed about pull request. This is the way you can quick and dirty way you can do it in isolation, and it is okay for demonstration purpose. And that's when you should explore the pull request to further optimize it, to make it more secure, to make it more more valid changes that is going to into the system. So that is the way, that is where a pull request system can come into the picture. Okay, yeah, Nitanshu, please go ahead to your next task.
Yeah. So the next for the next task, what we'll do is, so sometimes what happens is situation arises when there are multiple changes in multiple files. So like in the file in one of the class there is a change and another is the change in some another class of some another C# files. So what we want to do is we want to just commit the changes of the file one and not the file two because they are not completed yet. So what we'll do in that case, we'll just try to stage the changes and just commit the changes that we want to synchronize with the remote repository and not all the changes. So for that, we'll just go back to our Visual Studio and I'll just open one more file. So here I'll make one change as well. I'll just add on one more comment. I'll just save it. And in the first file as well, I'll make another change. And I'll save it as well. So as soon as I save both the files, the source control is showing me that we have two changes right now. So what I'll just do, I want to commit the changes only the only the cart item.cs file. So I'll just only want to commit the changes that I have made in cart item.cs. So what I'll do is I'll just stage the changes for this cart item.cs. I'll click on this plus icon and it has staged the changes. So now I have the option here. So in the Visual Studio Code that only the state changes should be published. So I'll just go click on these dots and I'll go to commit. And here I'll see the option of commit staged. So only the staged commits will be synchronized, will get committed. And I'll just type a message here only. Comments added. We'll go back to there. Commit staged. So as you can see, the changes for cart item.cs got committed, and here if you can see, we have one item that is pending for synchronization. So I'll just click on synchronize. And just completed now, and we'll go there and check. So now one more commit is there, which says comments added. So this is how you can review the commits and check for the commits that you are continuously making and review their history as well, that we have shown in the previous exercise as well. Now in the next exercise, what we'll do is we'll just try to review the history that we have made using the commits. So first of all, what we'll do is we'll just go back to Visual Studio Code and we'll click on this file. So in the source control, when we'll click on this file, category.cs, which is currently pending with one change, so it will open us two files in front of us, which will show us exactly the changes that we have made. So it is currently showing that line number 9 has some changes. So this is the same line that we have made some changes in. So this is how you can compare the files and also for reviewing the history that what all the changes were there earlier, and what all new changes have been made in the commit. So we'll just go back to commits, and we'll click on this one. Just a second. Yeah. So here we'll click on browse files. So in the browse files, it will give when we click on the history. So it will show us the uh, exact the time frame and the changes that we have made timely on this in this project one by one. So also what we can do is we can it also shows us the files that we have made changes on, right? And in the next part, what we'll do is we'll just start on working with branches. So just like Ashish told us that committing directly to master is not some best practices. So for best practices to be there, we should be creating some feature branches, dev branches for that. So we will be demonstrating that as well. So for that, what we'll do, we'll go to Visual Studio Code, and what I'll do is, just a second, I'll go back there and I'll click on this branch. And there you can see we have two options, that create a new branch and create a new branch from. So create a new, if I'll create a new branch, it will create me an empty branch with no coordinate. So what we'll do is we'll select this second option, create a new branch from. So what it'll do is it will create us a new branch, copying one of the existing branch that we will select later on. So what we'll do is I'll just create a new branch from, and I'll type in the branch name, that is dev. I'll press enter. So now it is asking me for the reference branch that I need to copy from. So I'll just click on master. So now you can see here in the left hand down corner that it is showing me I am currently in the dev branch. I am currently working in the dev branch. So right now this dev branch has been created in my local Git repository that is on my system. Now we need to replicate these same changes into our remote repository as well. So what we'll do is we'll just click on this small cloud button, which will publish our changes the to our remote repository in Azure DevOps. So it got completed. I'll just go back to my Azure and I'll go onto the branches. So there you can see it has created a dev branch for us. So as soon as we publish the changes from there, it got reflected here in no time. So now what we'll do is we'll try to replicate the changes back from Azure DevOps to our local Git repository. So what I'll do is I'll just delete this repository. Sorry, delete this branch, not repository, and I'll just click on delete. So now I have deleted this branch. So it is currently deleted from our remote repository and not from our local. So here, when I'll click on this, it is currently showing me this dev branch as well. And this origin slash dev branch is the remote branch that we have deleted. Currently, it is showing here because we have not synced the changes there. So what we'll do is we'll just check out from this branch and go onto the master branch so that we can delete that dev branch from here as well. We'll go into the master branch. So now that we are in master, and then we'll open the git command console that we opened earlier as well. We'll just press Control Shift and P. So it will open that command prompt in front of us. So what we'll do is we'll try to delete that branch from here, git. Then we'll click on delete branch. So now it's asking me to select the branch that I want to delete. I'll select dev and I'll press enter. So as soon as I press enter, it has deleted the branch. I'll just click on the master branch to see that if that exists. So you can see that it is not existing locally anymore in the dev, but it is still there showing that it is still exists remotely. So we will make we will be making these changes to remote as syncing the changes from remote to here as well. So for that, what we'll do is we'll type another command in the git console. We'll press Control Shift P again, and I'll just type git, then I'll fetch git fetch. We'll select git fetch prune. So what it basically does is it will fetch the changes made to remote repositories and basically delete the branch that we have deleted there. So we'll select git fetch prune. Just a second. Git fetch prune. Okay. So now we'll see that if the changes are made or not. So there you can see you cannot see origin/dev anymore, which was the remote branch that we have created in the Azure DevOps repository. So this is how you work with branches in the using the Git as well as the Azure repository. So in this exercise, we have created the branch from the our Visual Studio Code in our local repository. Same thing we can do it in the Azure DevOps as well. What we'll do is we'll go to the project, we'll go into the repository, and after that we'll go into branches. So like we have created the branch, we have created one dev branch in our local repository. So this time we'll create one dev branch from here. So we'll create a new branch. I'll name it as release, and it will be based on master, same thing that we selected there, that it will copy the content from master, and here we can link it to any of the work item, like Ashish told us that we can create multiple feature branches. So one of the any of the work items we can link this branch to, and as soon as that work item gets completed, we can delete this branch and merge the changes to our dev branch or and further move it to master. So I'll just select one of the work item. So suppose there was a bug in the system, so we have created a separate branch for to work on that code. So we'll just click on create. So there is a branch that is created there, which says release. So now we'll reflect these changes into our local repository using the Visual Studio Code. I'll just go back to Visual Studio Code, and again we'll open that git command console using Control Shift P, and there you can see we'll just type git fetch. We'll not use git fetch prune this time because that is for deleting. So now I'll just git fetch and click enter. So as soon as it gets completed, you can see that there you can see origin/release, which is the remote branch that we have created in our Azure DevOps project. Then what we can do is we will try to we can try to delete the branch from Azure DevOps project. So we'll click on branches. I'll try to delete it from here and hit here. Just a second. Yeah, here you can see the delete branch option. I'll click on delete. So sometimes what happens, we can some branches can be accidentally deleted if you have not applied any policies or locks into those branches. So what we can do is we'll try to search release, and there is no pipeline. You can see that no active branches found, but on the deleted branches you can see this that there is one pipeline that is there. So what we'll do is we'll try to restore this branch. So there is an option to restore the accidentally deleted branches as well that Azure DevOps keeps track. So we'll just click on the restore branch, and you can see that simply it got restored. And I will go back into the branches. You can see that there are some of the branches, and you can see that there is a branch that is called release. And for preventing it from the accidental deletion in the future, what we can do is we can apply locks. So we'll just go into that and we'll click on lock. So as soon as it got logged, it went into the delete read only mode. So we will not be able. So for deleting this, you have to go and unlock this branch, and then you will be able to make any changes and delete this. Now further moving on, what you can do is like Ashish told that you can tag the releases. So what we can do is we will just try to create some tags. We'll create a new tag and will name it as 1.1 and in the master, and we can description. In the description, we can just type on a simple that this is a great release. Just click on great.
Yeah, for the
So
background noise, guys who are not from India, we are having a very huge festival, that is Diwali. So happy
yeah,
Diwali, everyone! But yeah, forgive us for that. We cannot
yeah,
we cannot control that aspect.
can't do anything much
Yeah,
about that.
yeah. Just wanted to notify the other people who are not from India. Yep.
Yeah,
Please. Yeah, I mean, I got the comment here. So background noise is coming because some of the people are celebrating here. We have
yeah,
a light festival here. So just, yeah. I mean, we understand that, but we cannot control that thing. It is going over all over India. Yeah. Yeah, it's not gunshots, but yeah. Okay. So yeah, Nitanshu, please go ahead, continue. Yeah.
yeah, yeah. So we can create the tags as well. So like Ashish told that for the multiple releases, we can have multiple tags created. So I have created one of the tag here, and it will be tagged to one of our repositories in there. So now in the next part, what we will do is we'll just try to create a repository like we created in our local repo. So we will try to create the same repo in from this Azure DevOps project as well. So we'll just click on repos and we'll just click on this. Just a second. Yeah. Just a second. Yeah. So there is the option. So what we'll do is we'll just try to create a new repository. We'll just click on new, and you can select the type of the repository from here. So like Ashish told, we DevOps support two types of version control. One is Git and another one is Team Foundation version control. So we'll select Git from here, and I'll just enter a repository name, which I'll just call AZ-400 demo, and I'll just click on create. So now you can see that there is a repository created with one of the branch, which is master branch. You can add multiple branches using this new branch option simply, and it will just create some new branches for you. So you can also rename this repository as well. So what you have to do is for that you have to go to, just let me check the option for that. We'll go to repositories. We'll just go to project settings. There will be some for repositories. Yeah. So here are the repositories. So there you can see that we have created two repository. This one was earlier that we are using, and this is AZ-400 demo is the new one. So we'll just click on this. We'll select rename, and we can easily rename these repositories as well. And for deleting these repository, we can use the same option to delete them as well. So that's all for this demo. I hope you have you liked it. So Ashish, back to you.
Yep. Thanks, Nitanshu. Yeah,
Yeah.
sorry guys. Yeah, for the background noise, we understand. So those who are not from India, we just wanted to notify you. We have a celebration going on here. We fire, crackers, and those crackers are like, yeah, as you said, gun sounds like that. Okay. Anyway, so we are going to now we are going to start the Q&A, and post Q&A we are going to share the winner for the previous session. And before that, let me share my screen. Let me just give me a moment. Okay, so we have this. Okay, so we are going to share this is, okay, yeah. So this is the Q&A link. You can go ahead and okay, the date, forgive me for date. This is for previous one, but yeah, URL is the same. You can go ahead and open this URL and it will launch the quiz for today. You'll have to, enter the answer for the quiz, as well as you will have to, enter your username, your email and your name, and make sure you are registered on Eventbrite page, because we will be matching the email address from there, and then the combination of it will be selecting a few users to whom we will be giving free vouchers in the next session, just like we are going to give few after this quiz. So you will have 10 minutes to complete this quiz. After that, this link will be disabled. So please go ahead and open this link by scanning this QR, or open this URL azureeasy.com slash AZ dash 400. I'm going to post the same URL in the chat, so you can go ahead and open it from the chat as well. Just a moment. Nitanshu, can you post the URL in the chat? I'm not able to post in chats due to some reason. Okay. Yeah, my screen resolution. Sure. Okay, so yeah, we have posted the chat. You can directly open this link, and in the meanwhile, so we'll be coming back after 10 minutes. Your link will expire. So right now it's 10 o'clock IST. We'll be closing this link by 10:10. Please go ahead and we'll wait another 5 minutes. There are a few people who has completed. Okay, so we are almost there. Next 1 minute, we are going to close the link.
So Ashish, we are going to stop this quiz URL now.
Yeah, okay. Okay. Mhm. We'll see that, Pradeep. There are few people who are raising some question. Yeah, we will see that. Please go ahead and submit your answer. If at all it is needed, we will correct it during the evaluation. No, Manohar, it doesn't support any other format. Okay. Okay. So let's go ahead and go for the raffle for the people who participated last time. And we are going to announce few winners out of them. So let me share my screen. Okay. So, okay. Okay. So here are the list of people that we have that we selected last. I mean that participated in the previous session, and we have kind of a wheel kind of thing here for all the participant, those who have registered as well as they participated in the quiz, and we are going to run this uh, random link to generate dynamically the name that we are going to give the voucher to. So I just ran it for the first time, and let's see who is the lucky winner for this time. And the winner is okay. So Yadav RN is the winner. I'm going to copy this name. We'll search it over our information, and the person name is Rajkumar Yadav. So if you are here, we are going to contact you, and we will give you the voucher, free voucher for it. We run the wheel again and do it this. So let's see who is the lucky winner this time. And this time it is himapriya@gmail.com. So let me copy this one and let me find out what's the name. So the name is Himapriya. So Himapriya, we are going to contact you to give the voucher. Now let's run it again. So total 6 vouchers we are going to give away. And this time it's pnara.rao@gmail.com. Let me try to copy this and let me try to find out the name. Okay. So B Rao Narshima Boinapalli. Okay, so this is the name. We are going to contact you, Narsima, and via email. So far we have 3 people, and this is the 4th one. Let's see who is the one. Okay, Sudesh Kumar. So we are going to contact you, Sudesh. Congratulations. And you get a free voucher. So Sudesh Kumar, let me put it there. Okay. Okay, let me just do this, marking so that I do not forget. Okay, so now we are running the wheel again. How many? 4 we have. Fifth one. This one is with, okay, Carlos. We are going to give you. Okay, let me search Carlos. Control F. And this will be the last one. And Carlos, we are going to give you the voucher. Now this will be the last one. And let's see who is the lucky one. All right, Karan Prashar and Prashar. Awesome. Yes, sorry. So Karan, we are also going to give you the voucher by email. So let me copy this, Control C, and similar kind of Control F and this. Okay, Karan. Okay, so total we have 1, 2, 3, 4, 5, 2, oops, 1, 2, 3, 4, and 5, 6. So total we have the 6 people, and we will be running the similar kind of raffle next session. The list will be from the people who have joined this session today and those who have participated in the quiz. So you guys will be selected, and the list will be, and randomly we will be selecting 6 people, and we will give away the vouchers again. So similarly we will be selecting people based on their registration and the participation in the quiz, and hopefully uh, one of you would have won the voucher, or you will win the voucher in the next session. But having said that, I really thank you everyone for joining us today and staying with us for last 3 hours, and hopefully it has been uh, a fruitful session for you. Hopefully the expectation are met, and we will definitely recommend you to join our group, the Telegram group that we have, where we discuss Microsoft Azure or DevOps. So we have a DevOps group where we discuss DevOps related things, and we have a Azure Talk group where we discuss Azure related things. You can post any of your query. If we have not been able to answer your queries or questions, please go ahead and join our group, which is based on Telegram, and post your queries. We will be definitely happy to answer all your queries. If you have not registered for sessions, please go ahead and register the session by visiting this URL, azureeasy.com/az400. Registration of this, we will be having further sessions on different other modules. So far we have done 2 sessions covering 2 different modules of this exam, AZ-400. We'll be covering further topics in upcoming sessions, so please go ahead and register for the session so that you can get the timely updates and timely recording sessions URL, as well as the future session invitations. If you want to connect with Nitanshu, you can connect with him on this LinkedIn profile. If you want to connect with me, you can definitely go ahead and connect with me on this LinkedIn URL. You can also watch this web blog, which is my blog where I normally write things. Most of the time we are very much active on these DevOps groups because these are the best approach to be connected. We try to be we try to answer all the queries over there, whether real-time queries or whether you're starting your journey in the DevOps or Azure. We will definitely try to help you with the either with any of the level, from the fresher, from the beginner to the expert level, whichever we know, we will definitely try to help you there. We try to learn together. That's the motto of our community. Having said that, let's finish the session today. I think we are already up there more than 3 hours, and Again, thank you so much. Let's meet again and join our session on next, that will be posted in your group, as well as you can find the schedule on the Eventbrite page as well. Thank you. Thanks everyone. Have a good day and have a good night. Thank you. Bye bye.